Okay, so the last video that we're going to talk about is all about soil. So we're going to talk about what it's made out of. We're going to talk about how it's formed, and we're also going to talk about the soil's different properties. So the first question that I'll ask to you is, when you think of soil, what do you think it's made out of? Where does it come from, and why is it there? So it's actually a mixture of 4 different things. It's a mixture of weathered rock, organic material, so living or organic matter, so living things, air, and water. And there's actually about half of soil is air and water. The other half is a solid. So one half is solid, and the other half is liquids and gases. Good soil comes when organic matter is present, and that shows that plants and animals are able to thrive in that soil, which signifies that it is good soil. Soil scientists will classify soil fragments according to size. So sand, silt, and clay are all soil sizes. Sand is the largest soil fragment, and clay is the smallest soil fragment. So tomorrow, whenever we're doing our soil lab, we'll be feeling the texture of the soil. And if it feels rough, then it would be sand. If it feels smooth, it will be silt. Okay. And if it is sticky, then it will be clay. The organic part of the soil is mainly on the topsoil. That includes leaves, dead insects, waste from animals, and so on. So any organic matter that once was or that is coming from a once living thing. And organic matter is formed through decomposition from like mushrooms, worms, bacteria in the soil, and they form the organic matter in the soil. And what it does is it gives soil its nutrients for plants. It also holds water, and it gives soil its dark color. So that's why a lot of times the top layer of soil is very dark in color. The inorganic part of the soil, which has never been alive, is the result of mechanical and chemical weathering. So eventually those rocks break down into such small fragments that they become soil fragments. They're small enough to be considered soil fragments. Soil forming, there are 5 factors that make soil different in different places. So at your house, you're going to have different soil than if you came to school or if you went to my house and you dug up some soil there. Every different places have different soil properties. And it just depends on these 5 things. So parent material, what the rock is made or what the soil is made from or weathered from. It also depends on the particle size of the soil as well. Climate, so if there is a faster weathering rate, then the speed of soil formation is going to be different. Topography, so if you are on a slope compared to if you're at the bottom of a hill, you're going to have different types of soil. Biota is the living organisms in an area, so what type of living organisms you have in the area where you are. So if you are in a wooded area, you're going to have different biota than if you were in a subdivision. And then also time. So soil forming takes a very long time. It's very constant, but it's also very slow. And so it actually 1,000 years is still considered young soil. So that's pretty old in our terms, but that's considered young soil when it's 1,000 years old. Soil comes in different layers. So we're going to be looking at the soil profile tomorrow. So this is one example of a soil profile, and that's just looking at the layers of soil. So the A horizon, which I forgot to put horizon there, but the A horizon is the upper layer of soil. We call that the topsoil. The topsoil is, again, usually darker in color because of the organic matter that's present, and it has moderate pore space. So you're going to be able to hold a little bit of water in that area. B horizon is just below that. Also, you'll see this O horizon right here. That is all your organic matter on top of the soil. So that's your plants and all of that, and your roots and all that on top of the soil. Your B horizon is just below the A horizon. And that has very little organic matter. So we can see that it's a lot darker in the A horizon, but in the B horizon, it's a lot lighter. And remember, that's because the dark color comes from that organic matter. So it's usually brownish or reddish in color, and it contains clay. So it's very, very thin soil particles. And it also has very little pore space. The C horizon is the deepest layer of soil, and that is where parent rock is located. So the weathered rock was pushed down after a while, and the more looser particles are on top. Also, you're going to get a high pore space with the larger rock fragments, and it's usually light yellowish or brown in color. The properties of soil. So we're going to be looking at 5 properties of soil tomorrow, but there are other properties of soil as well. We're actually not going to be looking at the chemistry part of soil tomorrow, but I am going to make note of it. So texture, again, we're going to be determining whether it's rough, smooth, or sticky. We're going to determine, and the texture is determined by the size of the weathered rock. So remember, sand is the largest, clay is the smallest, and silt is somewhere in between there. The color, so most of it comes from either iron. If it's red in color, it's going to contain more iron. And the humus. The humus is just decayed plant animal matter. That's the dark color from the organic matter. So that's an important keyword there. Pore space is the space between the particles. So you're going to get a lot of pore space if you have larger particles compared to if you have a lot smaller particles. Okay, and we'll look at that tomorrow as well. Chemistry, so the pH, or how acidic or basic the soil is, which you'll learn more in 8th grade. But so the pH balance is considered, it determines how well plants grow in that area, which is very useful for farming or gardening. So chemistry, you'll look at the minerals and organic nutrients in there as well. Temperature, it needs to be measured in, oh, look, I guess I have a typo there. It needs to be measured in the place where it's found. So if you take soil from your house and then you bring it to the classroom and tomorrow we measure the temperature, that's not going to be an accurate read of the soil's temperature. You actually have to take it at your house. So we won't be looking at that either tomorrow. All right, so don't forget to bring in a sample of soil from your house. Remember, just if you cut out about an inch deep and about a 3 by 3 inch piece of land, then that should be plenty. And we will look at those tomorrow and compare our different soils from our houses tomorrow. All right, see you guys then. Bye.